Hello everyone, in this tutorial we will continue our ocean simulation tutorial part 2. Before we write the script, we need to create the parameter. This time we have this module locals. So we create integer. The name is size x and another integer is size y. This module locals, we can only use this parameter inside this diagram module script. It is ocean water set grids. And then module input, we add grid 2D collection. The name is displacement grid. This grid 2D collection, we use it to store the data in 2D dimension. So call grid 2D collection, FFT grid 2D collection, foam grid 2D collection, roughness grid 2D collection, spectrum grid, and then we add emitter attribute grid 2D collection, displacement grid 2D collection, FFT grid, the same as the input, grid 2D collection, foam grid 2D collection, roughness grid 2D collection, spectrum grid, and add integer is grid size, integer num cascade, integer roughness LUT size. Now let's create the node. For map get, we add grid size. This grid size is from emitter and num cascades. We get it from the emitter too, because we already initialize it inside this set initialize. Here is the grid size that we initialize. So we already have this value. And we map set it to size x and size y. And it is local because we only use inside this module, and multiply with this num cascade. This grid size to size x and grid size multiply with num cascade is size y. We can disconnect this first and we connect it later after we set all of the parameter. So comment on this, calculate size of the grid to store all cascades and store in local variable. I need to draw a little bit to explain this. This is the grid size, and then we have another grid and another grid, and this is the last grid. And example, this is X and this is Y. Because we have 4 cascades, so this grid size multiplied by 4 to store all the cascade. Next, we call map get and add FFT grid input and size X and size Y. Map set, and the output is FFT grid emitter, and this FFT grid we need to set num cell, and the cell of this is size X for num cell X and size Y for num cell Y, and we comment on this, set and resize grid for IFFT stage. Then connect this FFT to this grid. The same for other grid, we call map get and displacement grid size X, size Y. Then we set num cell with this X and Y, and we call map set add the displacement grid emitter, like this to displacement grid. Comment on this, set and resize grid for storing displacement grid. You don't need to comment if you don't want, just tell what it is working on this node. Map get and spectrum input size X, size Y, set num cell, this X and Y. Then call map set, add the spectrum emitter, this spectrum emitter grid, and comment is set and resize grid for storing spectrum. Continue map get form grid input size X, size Y, and set num cell X and Y. Map set add form emitter, set this form emitter, This one is set and resize grid for storing form data. And the last one, we map get at the roughness LUT size, roughness grid input, set name cell, by using this roughness LUT size to x and y is 1 because the y-axis only 1 pixel, and map set and roughness grid emitter, that is roughness grid. Get our output module, connect to this output map. Comment on this. Set and resize grid for storing roughness. Compile, apply and save. We finish this set grid module, and now we add another module, fx script, Niagara module script. Name is fx ocean water. Set render target. Open this, go to script, detail, set spawn and update emitter, and expose to library. Keyword is ocean water. Apply. And this one we don't do anything a lot, just want to initialize the render target, this pixel and vertex render target to the Niagara system. So module inputs, render target 2D, RT, pixel attributes has 0. We cannot duplicate or copy this inside this module input, so we have to add it one by one. Render target 2D, RT, pixel attributes has 1. Because we have similar names, so copy this name, add render target 2D, pass the name, set it to 2, render target 2D, pass the name, set to 3, and add render target, and the name is attribute B, has 0, and copy this, and then add render target 2D has 1, and cast 2, cast 3, and add render target 2D, RT, roughness, and add render target 2D array for vertex render target is RT vertex attribute. Sorry, this need the space. and add another one. Render target 2D array is RT vertex trips B, and add the same with this emitter attribute. You can copy this name, render target 2D, and the target 2D 1, just the same. Copy this, render target 2D, pixel attribute B cast 0, cast 1, cast 2, cast 3, and add another render target 2D is RT roughness. Copy this name, render target 2D array, RT vertex attribute, and the target 2D array, RT vertex attribute B. And then we add all of these parameters to this get RT has 0, RT has 1, RT 2, RT has 3. Continue to add all of these parameters. Here you finish. And this set map set the same. Add this emitter, and then connect all of this by the name of the parameter. Let's compile and apply. Now we finish setting the render target module. And let's go to FX Ocean Water and add this module to Emitter Spawn. FX Ocean Water set initial. And add FX Ocean Water set grid. FX Ocean Water set render target. We set this initial, this amplitude, search for amplitude and use this user parameter. Chop this choppiness, form blur, form fade, form injection, form threshold, gravity, long wave cutoff, edge length, repeat period, roughness sample, roughness power, short wave cutoff, wind direction, wind directionality, wind speed, and wind heighten. And water set grid, we use override buffer format. Can expand this and float. Override all of the buffer format of the grid. And now we have to set the render target for this pixel attribute. Just set it to the same name as the parameter. This user parameter is RT pixel attribute cast0 with this cast0. And this cast1, cast2, cast3. And this pixel attribute B is cast0, cast1, cast2, and cast3. And this one is RT roughness and vertex attribute and vertex attribute B. And we have to set the size. This pixel render target is 256 for X and Y. And override format, we use RTF or GBA 16F and 256, just set the same, or GBA 16F. And sorry, this one is 256 and 256 override. The same with this pixel attribute B, 256 override format is RGBA 16F. $256 and override $256 and $256 override RGBA 16F. And except this roughness, we need to set the size is 4096 and this y is 1 and set the format to all 16F because we only use one channel or channel. Set this map generation to post simulation and this vertex the same as other, just need the size is 256 and 4. Override format or GBA 16 256 and 4 cascade. Override format or GBA 16. Let's save and compile. You can open this render target and you can see this one we use the 4 channel alpha, blue, green and red. So it is RGBA 16 and the size we initialize it to 256. It is correct as we initialize in the Niagara system. And this is the roughness. It is 4096 multiplied by 1 and we only use this all. And this is the vertex. It is the size is 256 multiplied with 256 and 4. It's all correct. We can close all of this module. We arrive at this emitter update stage. So we need to update the animation time. It is the t variable in the equation because our wave will move through the time. So we need to create another script. Photo effect module emitter. This script, Niagara module script. Name is fx ocean water set per frame. And open this. Go to script detail and set it to emitter spawn script and emitter update script. Expose this. Keyword is ocean water and apply. Go to parameter and we add module input is float. Name is animation time. Add float. Repeat period. Add float is wind speed. And emitter attribute. Add float. Animation time. And float wind speed. And now we add it to the map get the repeat period input and get animation time input and get data time from the engine. So after we add this data time, it automatically add this parameter inside the engine provided category. And map set, add wind speed emitter and animation time. move it back and call another map get wind speed input and connect this wind speed input to wind speed input of map set. We don't modify it. We set this wind speed in the update because while we playing the game, this wave will change according to the wind speed. And this animation time called select if, and the select choose boolean greater than or equal, and connect it to the selector and use the repeat period to compare. Get this repeat period and call min with this delta time to ensure that we never jump more than one repeat period ahead, and add it with the animation time from the input. And we connect this to fall. So we connect this and this one compared to the repeat period. If it is greater or equal to this repeat period, we need to subtract it. Subtract with this repeat period and connect to true. So this animation time always loop in this repeat period. And compile and apply. Go to FH Ocean Water. In the update, we add this set per frame and next to animation time is emitter and repeat period is emitter and wind speed is user wind speed. Because this animation time it update everything and add with the delta time. The value is increased here until the repeat period, and then we subtract it and then start over again. Before we continue, we will create a few files for our project. I'll put the link in the description so you can go to this ocean simulation tutorial and go to spectrum tick simulation stage. You need to copy this code and open your project ocean tutorial, and you can create a new folder. Name is UHS File, and then add new text document, open and pass this code inside the perform multiplication of two complex number, and this one is addition of two complex number, and save. Copy this name and rename this to ocean complex math.ush and enter and click on yes. And inverse Fast Fourier Transform stage. Copy this butterfly pass and butterfly pass final, and go to the same place, new text document, paste this code and save. And then copy this name, Ocean Water FFT USH, and rename it to this Ocean Water FFT.ush and enter. Yes. Then this form, copy this and new text document, open and pass, get wrap position, save this, copy this name, ocean export.ush, and we pass this name, enter. And now we finish creating this UHS file. So let's continue with our simulation. We need to create another new state for our simulation, and this stage is to generate the spectrum. We use Phillips spectrum to generate the wave spectrum. Let's go to Effect module and create a new FH script, diagram module script. Name it FH Ocean Water Populate Spectrum. Open this and close this, and go to script detail, and this module we don't use this Spawn and only use this particle simulation state script because this is the new state of our simulation. And choose expose. Keyword is ocean water. Now go to parameters, and we need to add a new parameter. Module input is vector 4 amplitude, float, gravity, integer, grid size, and integer half grid size. Vector 4 long wave cutoff. Vector 4 patch length. Vector 4 short wave cutoff. Grid 2D collection. Spectrum grid. Vector 2D. Win DIO. Vector 4 win directionality, and float wind speed. And vector 4 is wind heighten. Then module local add integer, ignore map get, we get wind direction, wind speed, wind heighten, wind directionality, patch length, gravity, amplitude, short wave cutoff, long wave cutoff, grid size, and half grid size. And we call another map get is spectrum grid input. And then we move this a little bit and get 2 pi for random float, make vector 4, and this random float connect to x and y, and this one to z and w, and then copy this to pi and random float, copy this and paste for sine radian, and another one is cosine radian and sine radian, and cosine radian. Then make vector 4 like this, sine to x, cos to y, sine z and w, and then multiply this random value to this random value of sine and cosine vector 4, and this one is the random complex amplitude. And create a, and you can move this a little bit back here and create a custom HLSL. HLSL is high level shader language. The shader have its own language that created by Microsoft. So you need to know how to write this code, or you can copy from here, copy and paste it here. And now we need to add the variable for HLSL code. So add vector 4. The name is complex amplitude. And connect this random complex amplitude to this complex amplitude. And connect this spectrum grid. And wind direction, can rename it to wind direction. Wind speed, wind tighten, wind directionality, patch length, gravity. This amplitude, the gravity, we can rename it to G. And this amplitude, rename it to A, capital A. Short wave cut off, long wave cut off, and grid size, half grid size. You need to set this name exactly the same, because in this code we will use this variable name. Example, this G is gravity, and this A is amplitude. And add ignore to map set this local, connect it to this. Now let's compile, and we don't get any error, and apply. Now go to FX Ocean Water, and we add stage, add generic simulation stage, and we rename this stage to initial spectrum, and set it to direct set. Set this to 3D. This element count X is grid size, and grid size count Y, and count Z is num cascade. Because we have 4 cascade, and execute behavior is on simulation reset. And now let's add this new module, populate spectrum, and then we set all of the parameter. Amplitude, emitter, you have to set the emitter parameter, not the user parameter, because this emitter parameter already initialized in the system, and sometimes it also modify when it after it initialize. This patch length, short wave cut off, spectrum grid, wind direction, wind directionality, wind speed, and wind tighten. Let's compile. To see if it is rendered or not, we have to go to ocean water set grid, preview this spectrum grid, and preview. If you see the same texture, it means it is correct. And if you have different result, you need to debug it again. And we disable this preview. And now we need to simulate this spectrum over time. We need the new module. Create a Niagara module script. Name is FX Ocean Water Timestep. and open this module. Script detail. We disable all of this. Only use this particle simulation stage script. We expose to library and keyword the same as before, ocean water. Parameter and module input is float animation time, and add float base frequency, vector for hop, grid 2D, FFT grid, and float gravity, and integer grid size, integer half grid size, and then is vector 4 is patch length grid 2D collection, spectrum grid, and this module local integer is ignore, and get map get. We add the spectrum grid because we want to modify the spectrum grid over time. Map get, add patch length, gravity, grid size, add chop, half grid size, animation time, FFT grid, base frequency, and we create a custom HLSL. Go to this spectrum tick simulation stage, and we need to copy this code HLSL expression, paste it here, and the map set we add ignore, connect this to the custom HLSL, and this custom HLSL we add absolute include file path, and select the file that we create, UHS file, and choose this ocean complex map, and connect this spectrum to this add patch length, gravity, rename it to G, grid size, top, half grid size, animation time, FFT grid, and base frequency. Name it to base freq, and this G is small g, not capital letter G. And let's compile. Apply. We don't have any error. Back to FH ocean water. Add a new state, generic simulation state. Name is Timestep, and choose this iteration source is data interface. Sorry, not data interface, is direct set. And then choose 3D, grid size, and num cascade. Then add the new module is time step, FX ocean water time step. And this animation time emitter. Use all the emitter parameter. FFT grid, emitter, gravity, grid size, half grid size, patch length, spectrum grid. And let's compile, and we don't get any error. So go to ocean water set grid, and let's check this. And we preview this FFT grid. And if you see this grid that look the same, it is correct. And disable this. The next stage, we will use inverse Fourier transform to transform this spectrum from the frequency domain to the spatial domain. Thank you very much for my patrons member who are supporting me. If you like this tutorial, please hit like and please subscribe to my YouTube channel. Thank you very much for watching. See you in the next tutorial.